All right, hey guys, so we're going to continue moving along chapter 9. So this is day 1 of chapter 9. We're going to be talking about periodic functions, amplitude, and period. Okay, so we're going to be doing some graphing, and we will also look at this on our graphing calculators, but we're first going to learn how to do it by hand. Okay, just like with all of our graphs, all of our functions that we've studied so far this year, there are those 4 points that you need to have memorized to help you graph. Same thing here, okay? And I'm going to explain where the values come from your unit circle, but then you really just need to have them memorized so that you can work through them fast, okay? So we're going to be graphing x value 0, pi over 2, pi, 3 pi over 2, and 2 pi. So where did those come from? Again, we're on the unit circle, and I'm looking at the circle at 0 degree, or excuse me, at, 0 degrees. Then at 90 degrees, which is pi over 2. Then at 180 degrees, which is 2 pi. Or sorry, I'm pointing the wrong direction because it's backwards for me. Let me start over. We're looking at the graph at 0 degrees, and then at pi over 2 degrees, which is 90 degrees, then pi, which is 180, then 3 pi over 2, which is 270, and then 2 pi. So that's where these numbers come from, okay? And then we want the corresponding y values, okay, for those points. So the y values, let me make sure I'm pointing to the right ones as we go, are 0, and then 1, and then 0, and then -1. Okay, so that's where these values come from here. All right, so for sine of x, it's going to be 0, 1, 0, -1, and 0. For cosine, remember for cosine, it's x over r, so that's why I'm going to be using the x values this time. All right, so the first one is going to be 1, then 0, then -1, then 0. So for cosine, it's 1, 0, -1, 0, 1. All right, and then I'm going to plot those points. So I'm going to plot a point at 0, 0. I'm going to plot a point at pi over 2, 1. I'm going to plot a point at pi, 0. And then 3 pi over 2, -1. And then 2 pi, 0. Okay, and then I draw my sine function. All right. And then over here, plotting the points as well. I start at 0, 1. Then I plot a point at pi over 2, 0. Then I plot a point at pi, -1. Then 3 pi over 2, 0. And finally 2 pi, 1. It's going to go back down, so I kind of curve the ends down like that. Okay. So to graph, you want to know those core points, all right? And then we're going to be transforming them just like we transformed all of our other functions. Plot beginning, end, and middle, and then quarter points. The graphs are considered periodic or cyclic because they cycle through the same values. So this is one period, and I basically copy this pattern, okay? So it goes up to 1, down to 0, down to 1, up to 0, then it's going to go up to 1, down to 0, down to -1, up to 0. It follows the same pattern. So after you graph one period, you can just copy the pattern to graph a second period if you're asked to graph 2 periods. All right. The period is the length of the shortest repeating horizontal portion of the graph. So the period is pi over 2 for the graphs above, and that's important to know. The period is equal to, I think I said that wrong, the period is equal to 2 pi, I may have read that wrong, sorry guys, for both of these, okay? Because it repeats, one full cycle is from 0 to 2 pi, and then it's going to repeat. Again, along the horizontal, from 0 to 2 pi is one period, and then it repeats. The amplitude is the number of spaces above and below the midline. The midline runs through the middle of the graph, okay? So here, this x-axis runs through the middle of the graph, so this is your midline. So the amplitude is the number of periods above and below, okay? So your amplitude can be found, excuse me, your amplitude can be found by taking the max minus the min and then dividing by 2. And we also just write that as capital M minus little m divided by 2. All right. Okay, so let me write up the 2 functions that we're going to investigate today. So today we're going to investigate y is equal to a sine b x minus h plus k, and y equals a cosine b x minus h plus k. Okay. Now the amplitude is equal to the absolute value of a. Your period, remember I said the period is 2 pi, but if the graph is transformed, then the period is going to be changing as well. And the period is going to be 2 pi divided by the absolute value of b. Okay? Because the b value is going to horizontally shrink or stretch the graph, so that changes the period. All right? And what else do you guys need to know? So it's actually very similar to all of the other functions we studied as far as what do the values do, how do the values transform. It's the same. A, B, H, and K are the same for this function, so I'm just going to label them over here. All right, the A value is your vertical stretch or shrink. Vertical stretch, shrink. Your B value is your horizontal stretch or shrink. Your H value is your movement right or left, and your K value is your translation up or down. So this is going to be right, left, and this is going to be up, down. So again, same transformation rules as all the other functions that we studied throughout the year. All right, so it shouldn't be that hard to figure out the transformation that's taking place. Okay? All right. Okay. So we're going to work with a graph. We're going to identify the amplitude of the period, and then graph the function and describe the graph as a transformation of the parent function. Okay? So the parent function is going to be f of x equals sine x. And then the new function is going to be g of x is equal to 5 sine x. All right, so let's first graph the parent function, talk about that for a second. So key points, remember I said you basically just should memorize these, but you can go to the unit circle to get them as well. It's 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then it's 0, 1, 0, negative 1, 0. Okay, I'm going to graph that in a second. But let's figure out what's happening to the new function. Since that 5 is the A value, it's stretching the graph vertically. So if it's stretching the graph vertically, that means all of the Y values are going to be multiplied by that factor of 5. So you're going to multiply all your y's by 5 since it's a vertical stretch, okay? So the x's aren't going to change, but the y's get multiplied by 5. So the points are going to be 0, pi over 2, pi, 3 pi over 2, 2 pi, and then multiplying each of these by 5 gives me 0, 5, 0, negative 5, 0. Okay, so those are going to be the points that I plot when I go to graph. Let's talk about, actually let's graph first, then we'll talk about the amplitude and the period. All right, so One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, and then we have pi over 2. We have 5. We have 3 pi over 2. And we have 2 pi. Okay, so we'll graph the parent function first. So 0, 0. Then we have there. Then it's going to be here. Then it's going to be here. And then it's going to be here. Okay, so this is your parent function. And then the transform function, sorry guys, has the point 0, 0. Then it's going to be pi over 2, 5. Then it's going to be pi 0. Then 3 pi over 2, negative 5. And then 0 again. So you can see that it's stretched vertically, right? And we're going to talk about the amplitude and the period. Okay, so the amplitude is the absolute value of A. So for my new function, the amplitude is 5, because that's your A value. And the period is 2 pi divided by the absolute value of B. The B value is a 1, so it's just 2 pi over 1, which is 2 pi, which makes sense because, let's look at the graph now, this is one period. The one period takes place between 0 and pi over 2. So, or excuse me, 2 pi, which is what the period is. The amplitude, the max, right, above the midline, and the min below the midline, 5 units. So the amplitude is 5. Okay, for the parent function, the amplitude would just be 1, right? 1 unit above, 1 unit below the midline, and the period is still 2 pi. Okay. All right, we're going to do, I think, just one more graphing problem, guys. All right. Okay, so the next one we're going to look at is f of x equals cosine x, and g of x, let's do this one a different color, equals 3 cosine pi x. Okay, so let's start with the parent function. The parent function is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Alright, and the y values are going to be 1, 0, negative 1, 0, 1. Okay. So for transformation, let's figure out what the transformation is. I have an A value of 3 and a B value of pi. Okay, the A value is your vertical stretch or shrink, and the B value is your horizontal stretch or shrink. So the A value, since it's vertical, is going to affect the Y values, while your B value is going to affect your X values. Okay, so Since there is a vertical stretch of 3, I'm going to multiply all my y values by 3. All of these y values get multiplied by 3. All right. Now pi, if we think about pi as a numerical value, the approximation is 3.14. Okay. So that means that there is a horizontal shrink by a factor of 1 over pi. Remember, for horizontal stretches and shrinks, it's always by the reciprocal factor. So we're going to multiply all of the x values by 1 over pi. Can I decide? Yeah. Multiply by 1 over pi, or divide by pi, however you want to think about it. But you're going to do x times 1 over pi. Okay. So if I multiply all of the y values by 3, I have 3, 0, negative 3, 0, 3. Now I'm going to multiply all of these by 1 over pi. And if you want to do your work off to the side, you can. But 1 over pi times 0 is still just 0. Then this times 1 over pi. So 1 over pi times pi over 2. The pi's cancel, so it's just 1/2. Then you're going to multiply pi by 1 over pi. So 1 over pi times pi. The pi's cancel, so it's just a 1. Then I'm going to multiply 3 over pi. 3 pi over 2, times 1 over pi. The pi's cancel, so it's just 3 over 2. And then finally 2 pi times 1 over pi. 1 over pi times 2 pi. Again, the pi's cancel, that just leaves you with a 2. All right, so we're going to graph what we have. All right. 1, 2, 3, 1, 2, 3, and then I have. All right, so here we have radian, or we have pi over 2, pi, 3 pi over 2, and 2 pi, and we also have 1/2, 1, 3/2, and 2 along our x-axis. So we're going to have to put both. And I do have, and I'll post this, I do have graph paper that already has the values, so you don't have to figure it out on your own. All right, but I'll put the values. So here is 1, 2, 3, 4, and then we have pi over 2, pi, 3 pi over 2, and then we have 2 pi. Okay. So again, you'll have the graph paper that has all those values on it. So for my parent function, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and then 2 pi, 1. And it's very stretched out because I elongated, but it will go like this. All right, and then the other function is 0, 3, 1/2, 0, 1, negative 3, 3/2, so it's 1.5, 0, and then 2, 3. So you can see that it was both horizontally shrunk, right? It got skinnier this way. It's not as elongated. Horizontal shrink and vertical stretch. Okay, I think that's it. Let me just see real fast, see if I want to talk about any others. Nope, I think that's it. Oh, the period and the amplitude. We didn't talk about that, and then we'll be done. All right, so the amplitude is the absolute value of A, so the amplitude is 3. And the period is 2 pi divided by the absolute value of B. So it's 2 pi over pi, which is just 2. which you can see that it goes, the horizontal distance that the red graph goes from is from 0 to 2. Right? And that is it for that graphing lesson. All right, guys, jump on to the online textbook, get that homework done. I'll see you for day 2 later on. Bye.